Hey guys, welcome back to my channel. So today we are going to look at a DSA problem, that is remove nth node from the end of the list. It's a Leetcode medium level problem. So given the head of a linked list, remove the nth node from the end of the list and return its head. So 1, 2, 3, 4, 5 is the nodes that are given of the linked list, and n is equals to 2. So we need to remove the node from the end of the list. So that is why 4 gets removed. And basically by removing what we mean is a delinking happens. So the node connection between 3 and 4 is broken, and 3 gets connected to 5 as the next node. Sorry, means 5 gets connected to 3 as the next node. And for example 2, we have just one node in the linked list, and if n is equals to 1, then we get an empty list. And in 3, we have head is having two nodes and n is equals to 1. So 2 gets removed and we just have 1. Okay. So for this question, we need to consider a dummy node. So why we are considering a dummy node is to handle one of the edge cases. That is, if you have a linked list like this and n is equals to 2, that means 1 is to be removed, but 1 is the head, right? If we remove this, then how will we get back this as the answer? And this needs to be given back to us as an answer. So that is why, like, if such a situation arises, we need to keep a copy of the head. So for that same reason, we are going to maintain a copy of the head in dummy. So dummy's next will be pointing to head. Now coming to a question, we have n is equals to 2, right? So one thing that we can do is we can traverse from the beginning, because in linked list we need to do the traversal from the head. So from the beginning we can count the number of nodes, that is 5, right? And then we can just get the point before the one that is supposed to be deleted. So c minus n is 3 in this case, right? So we would traverse till 3, and then we know that 4 is the node that is to be deleted, and we have reached the point before that node, that particular node which we are supposed to delete. So we can just simply break this link, right? And we can have 3's next node as 5, and we get our answer. Another approach to handle this kind of question is we can use two pointer. So we will be having two pointers, both starting from the beginning of the node. Okay, but there will be one pointer which will traverse ahead. Okay, so let's keep it as the red pointer. Okay, my red pointer is going to traverse here, here, and here. And how do I come across like where it is going to stop? So basically it is just going to traverse n plus 1 distance. Okay, so we will run another loop where one of the pointer will just reach this particular node, and the distance between the first node and this node is going to be n plus 1. Okay, why we are maintaining this is because this distance ensures that when this node is going to reach null, then this particular node will be at a spot which is prior to the number which is getting deleted, because the distance is n plus 1, right? For that same reason, we have maintained the distance as such. And if you have to look at the traversal, because in the next loop, we are going to make these two pointers travel together, one being ahead of the other. So what is going to happen is we see that this is going to reach here, while the red node is at 5, the blue is at 2, then the red node reaches null. When it reaches null, we see that the blue node is at, or the blue pointer is at 3, which is a point before that node, which we are going to delete, right? And yes, that is exactly what we need. We want our slower node or the blue node, whatever you may call it, to be at a position so that we can just make this delinking possible and we can connect this to node. So that is what we are going to do. So let's code it. So our dummies next is going to point to head, and we will have two pointers. Let's call it fast. This will also point to dummy, slow. This will also point to dummy. Now the faster node needs to traverse a certain distance, that is n plus 1 distance. So our faster node is at n plus 1 distance from the blue node or the slow node. So while fast is not equals to null, and while we are done with this code snippet, we will be at a position where our slower node is at 3 and our faster node is at null, right? So we just need to perform the delinking now. So slows next should be pointing to slows next. So this particular part means 3. So 3's next should be pointing to slows next. So slows next currently is 4, right? And what is 4's next? That is 5. So that is why we need slows next dot next. So 3 is pointing to 5, and we simply need to return dummy dot next. So talking about the time complexity, as we are traversing through the entire linked list, it is going to be O of n. Okay, O of n, and space complexity would be O of 1 because we are just adding one node as a dummy node. We are not using any data structure which is of the length of the entire linked list or length of n. So this is what, and I'm hoping you guys understood this. Thank you so much for watching. Let's catch up in the next video.